Good morning. We continue with nucleophilic addition reactions of aldehydes and ketones. Next is addition of hydrogen cyanide. Addition of hydrogen cyanide. The product name is known as cyanohydrin. Cyanohydrin. Okay. So let us see what is cyanohydrin. Example. CH3COH acetaldehyde react with the hydrogen cyanide HCN, that means H plus and Cn minus. Cn will attack on positively charged carbon. The bond is shifting to oxygen, then the positive part H plus is attaching to oxygen and we get CH3CH. Here it is Cn and here it is OH. This compound is known as acetaldehyde cyanohydrin. Cyanohydrin. Okay. Next, if you take ketone CH3CO CH3 acetone react with HCN, but we get same reaction, H plus and Cn minus will attack on this carbon. Okay, now we get CH3C, here it is CH3, here it is Cn, and here it will become OH. This compound is known as acetone cyanohydrin. So when aldehydes and ketones react with the hydrogen cyanide, we get cyanohydrin. Acetaldehyde react with the hydrogen cyanide, we get acetaldehyde cyanohydrin, and acetone react with the hydrogen cyanide, we get acetone cyanohydrin. These cyanohydrin intermediates are very useful compounds, or these are very useful intermediates. Which are useful intermediates? These cyanohydrins are useful intermediates for the preparation of alpha hydroxy acid and similarly alpha amino compounds. That means when cyanohydrins undergo hydrolysis, we get alpha hydroxy acids, and similarly when cyanohydrins undergo reduction, we get alpha hydroxy amines. So look at it here. Okay, this is acetaldehyde cyanohydrin. As I told you, when these cyanohydrins undergo hydrolysis, H2O, H plus, what will happen? This Cn group will change into COH. The Cn group will change into COH. So what we get? We get CH3CHOH, and here you can see that the Cn group is changing to COH. Okay, that means we get alpha hydroxy propanoic acid, or which is known as lactic acid. Okay, so when acetaldehyde cyanohydrin undergo hydrolysis, or in general cyanohydrins undergo hydrolysis, what we get? We get alpha hydroxy acid. Example, acetaldehyde cyanohydrin undergo hydrolysis, the Cn group will change into COH. Therefore, what we get? CH3. This is CH, COH. Cn group is changing to COH. The acid is known as lactic acid. Similarly, when it is undergoing reduction, okay, when it is reduced with LiAlH for lithium aluminium hydride, say reduced with lithium aluminium hydride, what we get? This Cn group will change into CH2NH2, that we have studied. Cn group is changed to CH2NH2. Therefore, what we get? We get CH3CHOH, and the Cn group when reduced is changing to CH2NH2. Okay, this is alpha hydroxy amine. This is, what is this one? 1 amino, 1, 2, 3. So 1 amino, 1, 2, 3, 3 carbon alkane, propane, and since the OH group is in the second carbon, propan 2 ol. Okay, okay, we get 1 amino, propan 2 ol. Okay, that means as I told you, cyanohydrins are important intermediate for the preparation of alpha hydroxy acid and alpha hydroxy amines. Okay, I think it is clear to you. Similarly, this also acetone. Acetone on hydrolysis, what we get? CH3, COH, CH3, the CN group will change into COH. And on reduction, what will happen? CH3, COH, CH3, the CN group will change into CH2, NH2. That's all. Okay. Next is addition of sodium bisulfite. What is that? Next is addition of sodium bisulfite. Addition of sodium bisulfite, not sulfate, sulfate. That means NaHSO3. NaHSO3. Look at here what we are getting. Example. We take acetone, CH3CHO, acetaldehyde, CH3CHO, COH, react with the sodium bisulfite, NaHSO3, that means Na plus, and HSO3 minus, so what we get? This minus part will attack. Okay, so what we get? CH3, CH, here it will become ONA, and here it is HSO3 or SO3H. Now you can see that there is a proton transfer. That means this proton H plus is migrating to oxygen and Na will come to this position. So what we get? We get CH3, C. Here it will become OH, and here it is H, and here it is SO3N. This is acetaldehyde sodium bisulfite. Acetaldehyde sodium bisulfite. This is a simple reaction. Okay, look at here, CH3CHO, Na plus and HSO3 minus. This will attack here. So what we get? We get in the first step we get ONA, HSO3, H, and this step is known as proton transfer. Then it is very clear. This proton H plus is migrating to oxygen. Na is coming to the position of H. So what we get? CH3, CHOH, SO3, Na. What is the compound name? Acetaldehyde sodium bisulfate. Similarly, if you take acetone, what you will get? Instead of H, what will come here? CH3. So it's the compound name is acetone sodium bisulfite. Okay, there is no difference. Only in the position of H, what will come? CH3. Okay, that is what is called addition of this reaction is known as addition of sodium bisulfite. Next is addition of alcohol. Next is addition of alcohol. First we get hemiacetal. Then we get acetal. So addition of alcohol. Look at here how this addition of alcohol is taking place. Say a general example, RCHO, aldehyde. I am taking aldehyde. React with an alcohol R dot OH, correct? R dot OH, and in presence of dry HCl. You can see that RO minus and H plus. Therefore, this negatively charged part, okay, will attack here, and okay. Then what we get? We get R, C, H is going to oxygen. Then here it is H, and what will come here? O, R dash. Correct? ROH means what is that? ROH, R dot OH. And this part is OR, this is minus, and H plus. Okay. And what do we get? This compound is known as hemiacetal. What is that? Hemiacetal. This hemiacetal will react with another molecule of alcohol. That means one more molecule of R dot OH. Correct? R dot OH. And what will happen? Look at it here. H and OH. H and OH will be eliminated. Minus H2O. So what we get? We get a structure like this. R, C, what will come here? OR dash. And here it is H, and here also OR dash. This compound is known as acetal. This is known as acetal. So in the first step, you can see that simple nucleophilic addition. The nucleophile OR minus is attacking, and we get hemiacetal. Again, it is reacting with one more molecule of H2O. or you can anyway you can here it is H and here it is OH. That way also you can show H and OH. Anyway, minus H2 will be eliminated, and what we get in this position also we are getting OR dash. This compound is known as acetal. Okay, and let us go through a specific example for addition of alcohol. Look at here. I'm taking acetaldehyde CH3 C double bond OH. Acetaldehyde is reacting with ethanol C2H5OH. Okay, in presence of dry HCl. What is the mechanism of the reaction? As I told you, C2H5O minus and H plus. This will attack here. Okay, and what we get? We get a structure like this: CH3 CH. Here it will become OH, and here it will become OC2H5. What is the name of this compound? Acetaldehyde. Look at here. This is ethyl group. Ethyl. Then add hemiacetal. Okay. Acetaldehyde, ethyl, hemiacetal. Again, this will react with another molecule of C2H5OH. Okay, how this reaction is happening? I am writing the same structure once again. CH3, COH, H, but this one O, C2H5. I am writing the same structure. And here you can see that C2H5 OH. Okay, what will eliminate? H2 will be eliminated, and what we get a structure like this: CH3 C H. Here it will become O, C2H5, and here also O, C2H5. What is the compound name? Acetal. Again, acetaldehyde. There are two ethyl group: diethyl. What is that? Acetal. Diethyl acetal. This is acetaldehyde, ethyl, hemiacetal, and this is acetaldehyde, diethyl acetal. Clear? Another example. If I take a ketone. Suppose I am taking a ketone. This is a ketone. Okay, double bond. What is the name of this ketone? Cyclohexanone. Suppose cyclohexanone is reacting with methanol, CH3OH. Okay, what will be the product? Okay, look at here. That means again the same thing, minus and plus. This will attack on this carbon. This bond is shifting to here. So what we get? Look at here. What we get? We get a structure like this. Okay, here it will become OH. Because H plus is attaching, and here what we will get? OCH3. Correct? OCH3. What is the name of this compound? Cyclohexanone. See, methyl. What is that? Hemiacetal. Okay, in the next step, it will react with another molecule of methanol, CH3OH. Okay, CH3OH, what will be eliminated? H2O is eliminating, and what we get? We get compound like this. Here it is OCH3, and here also OCH3. What is the name of this compound? Cyclohexanone dimethyl acetal. Clear? Okay, another example for addition of alcohol. Look at here. Suppose for the examination, a question is like this. Look at here. Again, we are starting with the cyclohexanone. Cyclohexanone is reacting with alcohol, dihydric alcohol. Okay, look at here. And your question, in presence of dry HCl, what will be the product? Okay, and when you look at the question, you must know that this is addition, this is a ketone. Okay, COR, this is a ketone. Ketone react with the alcohol, then you must know that this is a nucleophilic addition of alcohol into a ketone. So, how is the mechanism is proceeding? Look at here. Okay, here it is like this. Okay, you can see that here it is, look at any end. Okay, I am taking this end, that means this is O minus and this one is H plus. So what will happen? This negative end will attack here, and this bond is shifting. H is coming here. So what we will get? Here it is OH. and what will form? Here it is O, and here you can see that this is CH2, okay, and again this is another CH2, and again another CH2, another CH2. In that CH2 there is OH. Once again repeating, this is O minus and H plus, and this entire part is coming here. O is, see, this is attaching here O, then what is that? This CH2 is this CH2, 1 2 3 CH2. So what is that? CH2, CH2, CH2. In that there is OH. Correct? Correct? Okay. Now you can see that in the next step what will happen. This is the first step. What is that? This H plus, this only this H plus is coming to this O, that is OH. The entire part, this part is, this O minus is attaching to this carbon. So O, then this CH2, then this CH2, then this CH2 is here is a CH2 and OH. And in the next step what will happen? H and OH will be removed. Okay, so minus H2O, and we get a structure like this. Okay, here it is O, here it is also O, alright. Okay, you get a structure like this. Correct? Here minus H2 is eliminated, then this oxygen is coming here, and you get a structure like this. Okay, so that's all about addition of alcohol. And next one, the last one, addition of Grignard reagent. Addition of Grignard reagent. This we have studied. Okay, addition of Grignard reagent. Grignard reagent. Okay, this we have studied during the reactions of preparation of alcohol. Okay, from aldehydes and ketone. Now, what do you mean by that? First one, formaldehyde will give primary alcohol. Okay, what do you mean by formaldehyde will give primary alcohol? That means formaldehyde, HCHO, on addition with Grignard reagent, example CH3 MgBr, CH3 minus and MgBr plus, minus part is attacking. Here what we get? We get in presence of ether. What we get? HCH. Here it will become OMgBr, and here it is CH3, which on hydrolysis H2OH plus what we get? CH3. Okay, first CH3, then CH2. This part is changing to OH. Okay, plus what will form? MgOH This we have studied earlier. What is the next one? Other aldehydes will give secondary alcohol. Okay, example, other aldehyde means we take acetaldehyde, CH3 CHO, C double bond OH plus I am taking a Grignard reagent, cyclohexane, MgBr, magnesium bromide. Okay, this Grignard reagent I am taking. So look at here, in presence of ether, what will happen? That means this carbon, this is negative. Okay, this carbon is negative and MgBr plus. So what will happen? This is attacking here, and what we get? We get a structure like this. Okay, CH3CH. Here it will become OMgBr, and what will come here? Here it will be the Re. Correct? And in the next step on hydrolysis H2OH plus, what do we get? We get CH3CH. Here, okay, CH3CH. I can write the ring here also, no problem. Ring is here. Okay. Ring is here. Okay, and here it is OH. Clear? Okay, and this is a secondary alcohol. And the last one, what is that? Ketone on addition with the Grignard reagent will give tertiary alcohol. Okay, that's all about the addition reactions of aldehydes and ketones. We will continue in the next class. Thank you.